Okay, I think I'm live again. Let me see. So I lost internet connection. Yeah, I think it's working now. Ah man, this sucks. Am I live? Okay, yeah. It's working. I don't know what happened to my internet. But anyways. So yeah, I was talking about that trimming at around 5.4 mil, and I think somewhere here we have a trimming length of 12. So we need to add this to our motor params. Let's call this trimming offset, I think, and trimming length. So trimming length is going to be, oh, it's right here, it's 12. And the trimming offset is going to be 5.4 mil. So this is our offset. That's our trimming length. Cool. And now we need to go back to our motor, make it active. And we need a datum plane somewhere. Probably we'll start from here. Yeah, I think we're gonna do just that. So we have a datum plane here. We're gonna create a new plane, attach it to it, and in the Z direction, we need to go by pin length. Cool. Cool. And now we can create sketch here, go to section view, and let's do that trimming. So let's assume we have a circle here. We can just redraw the original pin. This was called motor holder params.pin offset. And this was motor params.pin diameter. Okay, and now I'm gonna set this as construction geometry. Pex Peppers, I need to ask, how does FreeCAD compare to, say, Fusion 360 in terms of ease of use? At the moment, it's not easy to use compared to Fusion 360. So yeah, if you like put the time and effort to learn it, you could do stuff. I mean, I'm doing stuff with it, no problem. But they're working on version 1 that should be released soon. They don't have a release date to it yet, but if you go to FreeCAD, what was it called, releases or something? Oh, come on. FreeCAD releases on Google. Yeah, you can see the release notes for version 1.0, which is again not released yet. And I don't know why it opens in Arabic for some reason here, but everything else is in English. It will tell you here that it's under development. There is no expected release date yet. You can download it and install it, but it's not a stable software yet. However, version 1.0 is introduced lots of ease of use features. So it's getting closer and closer to Fusion 360, but it's not there yet. So So yeah, they added lots of stuff, especially to, I think, Sketcher. Where is it? Sketcher, somewhere here. We can probably search for it. Sketcher. Sketcher Workbench. So they added lots of stuff which was missing. Like for example, the dimension tool, where you click D and you select anything or 2 points, for example, to enter the dimension between them. FreeCAD did not have this. Now it's there. There are lots of stuff that they added, and you can see it's a really big list. But we're still waiting for it, so hopefully we'll get it soon. Yeah, but if you have any questions about FreeCAD, just you can join my Discord server. I think I created a channel for FreeCAD that no one is using at the moment. FreeCAD, yeah, right here. You can ask any questions you want about FreeCAD and we'll help you out. So we want to make it trimming right here. So I'm gonna create a line that is constrained to this circle, and they're saying that it's 5.4 mil. I'm assuming this is the length or what? No, it doesn't look like the length. Let me see. I think what they mean, I'm just gonna enter it right here for now, and then we'll change it, like 5.4 divided by 2. No. Is it 5.4? Like that? No. That's interesting. This is interesting. Trimming 5.4 mil. Okay, wait. If we draw a line from here, or it doesn't matter, because we can just do this as I did. I'm gonna go with this. I think that's it. So this is not actually an offset. So the offset here, if this was an offset, would be like 0.2 because the diameter is 6. I'm gonna keep it called offset for now. And this is going to be the motor params dot. This will definitely change later once I know what it means. But I'm gonna assume it's this for now. And then to cut, I am going to, we can trim this. So if I get the trim tool, trim this, and then we're left with this, but I don't want it to be construction. Oh wait, it's not construction. Nice. So now I can use this sketch to pocket. And then how much do we want to pocket? This is motor params dot trimming length. But yeah, I don't know, does this look like this? Maybe it does. I think it does, judging from this section right here. I think I nailed it. Cool. So maybe this will help us put like an attachment here to connect whatever is going to be between these two. I'm still thinking whether I'm going to leave it like that, where we just squish these two parts between the lure, or we're going to have something like a magnet bar or something like this, where we can attach the lure to. I was telling you in the video that it was cut off that if you manage to lower the temperature in the motor compartment enough so that it doesn't get hot, it doesn't matter where you put it. Yes. I think you're talking about the fan. I saw the comment. I don't know what happened to my internet connection, and it just stopped my stream. You are right. It doesn't matter that much. It could be anywhere. And also what was it called? The power supply is gonna have a fan of its own. Probably, I think it's gonna draw air from the inside and put it out from the back. So there's gonna be airflow going on, and everything I'm using is very low wattage. So it's not gonna generate that much heat anyways. So yeah, we're fine. We're fine with the fan placement. And we're also fine using only one fan. We don't need more than one. What else do we need to do? Okay, yeah. So we need to somehow now I need to decide what I need to do here. Because what I have in mind so far, but the problem is that what I have in mind will not work for everything. So what I have in mind is we're gonna have something similar to this on this side and then squish it. So squish the lure in the middle and then it's gonna start rotating. However, there's a problem with that. What if you're doing a two-piece lure and you haven't assembled it yet, like a two-piece swim bait, then you cannot like squish it because it doesn't have like a line tie and a hook hanger. Or what if you're doing a lure that has like a deep diver where the line tie is like in the middle of the lip? It will not work. Excuse me for the question. Sure, you talk about already. How tall is the device? So we can change that whenever we want. I can go here to general. The height is 150 at the moment, but I can make it like 250. And I hope it doesn't crash. I should have saved. But yeah, we can do that. So I'm not too worried about the width, height, and everything. Everything from like every single parameter can be changed. So yeah, I'm not too worried about it. These are just numbers at the moment. Yeah, so we can make it wider. We can make it like taller. And what did I do? Oh, I changed the width. What was this? This is 150. Yeah. So, I think we need to make it tall, and then we can have a bar going from here, and then we can attach stuff to it. Or we can make a like a cylinder, a cylindrical thing on two sides. We can have like a cylindrical thing on two sides with no, this will not work. For that to work, this has to be fixed in its place, and it's not. So I think the bar is gonna be a better idea, and then imagine having two, like one bar here, another bar here, and maybe even a third bar here. That would be amazing. So you can put as many lures as you want, or only one of these with like a long bar. But the problem is with the limit of 3D printers, like mine, for example, can only print up to 250 mil unless you do it diagonally across the bed. You could print something that's like 300 mil, but I don't think you can do more. So this is probably gonna have a couple. We're gonna get rid of this mouse ear. Anyway, so let's hide this. What was this called? Lure holder. Let's hide this, but before we hide it, how did I do this subtractive helix? Probably need some info from it. Subtractive helix. Let's hide it and let's somehow get something similar to this in here. Oh wait, we have a problem. We have a problem. When I modeled this, when I basically modeled everything in here, I was under the impression that this part is gonna be like in the center of the motor, but this motor is a bit different. It's like offset, a bit offset. So what I can do is I can either lower the motor down or raise this up, which I think I'm gonna raise this. Let's see how easy it is. So right here we need to start adding, like for example, plus motor holder params dot, I think motor pin offset is what we called it, and then we can start raising them up. Hooks in the side, a magnet, a bar slide to the side. It's one of the most interesting things of your, yeah, exactly. I think this is what I'm gonna do here also. So you see this screw, I'm gonna also do a similar screw on this part, and then we can basically start working on attachments, and then you guys, for example, can create your own attachments. So this is what we're gonna do. The only difference between this and the older one is the threads. On the older one, I think I was using actual threads, but they don't print that well. And now I'm experimenting with these types of threads, like custom made. But let's see if this is all just prototyping and design at the moment. So anything can change in the future once I actually like start printing and assembling. Motor holder params dot motor pin offset. I should probably copy it because I'm gonna write it in lots of places. So let's copy that. Bearings, the same. We're gonna change the Z value for this one. Bearing 2, same. So the bearings are up now. Now we need to move these holes. That's in the moving platform. Oh man. What are these binders? Interesting. Pocket, what is this sketch? That's one. So open that sketch right here. Let's add this. Okay, close. That's one. Let me hide the screws and the bearings because we have another problem. There's a pad here. I think it's this one. We're gonna add to it also the offset. And this should be all. Anything else? Like here, okay, what is this? This is the same. And then we did here, here, multi-transform. Okay, cool. Now we can show these. Lure holder, no, we don't need it, but just for now, let me also fix it, because why not? Screw, bearing. Now they are in place. Now they should be exactly in line with this. Are they though? I think they are, because we have a notch at the top. Should be somewhere up here. Let's trust the math for now. Okay, let's see this screw here. Can we reuse it? What does it look like on the inside? It's just a... No, I don't think we can reuse it. Or actually, I think we can. Wait. Because I don't feel like remodeling it from the start. So if I go to part design and then I clone this, it's gonna be this body right here. So this had an X position that we can copy. And then we can go to the new body and we can do the negative of it. And then where are we gonna end up? Interesting. We are going to end up oh, okay. So right at the beginning, like at 0. So now I wanna add to this. Okay, wait, no, don't add to it. Let's remove the thickness. Minus thickness divided by 2. That's an interesting... But it works for some reason, so I'm gonna leave it. If we add the thickness, then we're gonna start from here. Basically, we're gonna start from right here. Okay, no. I think I got it. So let's go back to 0. Okay, and let's hide the motor holder and just look at the motor. So now we are right here. We need to go back by another tolerance. So gonna multiply the tolerance by 2 and then we're gonna be exactly at this line right here. So I wanna add to this. Oh wait, but now what's gonna be body right here? What's gonna be this value is our, yeah, it's called, so plus motor params dot pin holder length plus motor params dot pin length plus or minus motor params dot what did I call it? Pen? No, not pen. Where's AliExpress? Trimming. Oh wait, I have to retype it. Come on. Motor params dot pin holder length plus motor params dot pin length minus motor params dot trimming length. So now if I take this and let's enable transparency so we can see like on the inside what's going on. So we have a trimming here, and this is exactly on the trimming, but I want to move it by an offset. So going back to this value, I want to move it by a tolerance, right? So here we don't need to multiply by 2. Actually, yeah. Okay, cool. Cool. Now we have a tolerance also included. So now what we need to do is I'm gonna get rid of whatever we have here on the internals and right here, whatever we have here, because these are meant for like the bearings and stuff, but I want to reuse this, so that's why I cloned it, and now I'm gonna start like modifying it. So let's hide the motor. Let's keep this part, and let's hide the fan, board, power supply, moving platform, base plate. I don't need all of this. Let's isolate this. Cool. The first thing I'm gonna do is, first of all, where's the origin for this object? Oh no. Why is it like that? It shouldn't be like that. That's very interesting. That's probably because of the cloning. That's gonna be a mess. That is going to be a mess. Let's see if we can do anything about this. So I'm gonna show the screw again. Screw 2, I think, yeah. How can we clone this but without create a new shape binder? Subshape binder. Like if I created a new body, create a new body, and then I click the screw and create a shape binder. Click OK. Where is this body now? No, it's the same issue. The origin is here and the body is here. So that's not a solution. Was something... the old thread works perfectly. Yeah, it works perfectly. You mean with what? With the parts I printed, or the printed parts? Yes, it would work. But this will work much better if you're using my printed files. Because I mean, it's gonna print nicer. You're not gonna have like print issues. If you don't have much cooling in the printer, like if you have a cheap printer, you should be able to print these far better than the old ones. But again, I still haven't tested these, so I might revert back to the old threads. Also because I'm currently using a different software than before. So threads here are a bit different than in the other software. I don't know yet how to do them. That's why I did these custom threads. Yeah, so the biggest issue now is the origin. Let me see how how I can fix that. If I can get one datum plane up here, then we can work. So wait, let's see. I think this is how it's gonna be. If I copy this and then create a datum plane, so we need to mark this as active, create a datum plane, attach it to this, and then in the Z direction we can move it by this amount. It should be exactly here. Now in Y direction it will go which way? I think X is what I want. That is interesting. Does nothing. Y is which way? Let's set it to some value like 26. I want to see what happens. What will happen when I create a sketch here? Okay, so it moved up. So this is what we want, Y. So I'm gonna click the datum plane, and in Y direction, it should be general dot height minus general, not general, motor holder params dot motor diameter divided by 2 minus motor holder params dot motor offset from top. And I also need to add to that the motor holder params dot pin offset. So now if I create a sketch, where is gonna be, wait, what? Okay, cool. The origin is gonna be right here. Nice. Okay, problem solved. Problem solved. We're gonna use datum planes. And let's see. The first thing I'm gonna do, let me hide that screw, is I need to cover up whatever is on the inside of this. So I have this hex screw. I think that's like the biggest thing on the inside. So I'm gonna create a circle to cover this hex. And the value for this hex is somewhere here. Is it in fasteners? I think. Yeah, I think it's in fasteners, not width. So how do we do this? We can do a, where is it? Hexagon. And then if we take the distance between this and this from fasteners dot not width, this is not correct. Why? Why is it not correct? Tool parameters, rubber parameters, rotating screw params, screw length, thread turns, bearing tolerance, bearing width. No. Is it the nut height? No, it shouldn't be. Oh, we need tolerance. Oh my god, I feel dumb. Plus, is it general though? Is it the general tolerance or do we have tolerance here? I think it is the general tolerance, so I'm gonna use the general tolerance. Multiplied by 2. Okay, there is a way to find out. So we're gonna go to screw number 2. Screw number 2 is a clone, so we clone the clone. Nice. Screw number 1. Let's see. What do you have? This is, I think. Yeah, that's it here. What is you? Fasteners.knot width plus fasteners.tolerance. Okay, cool. That's what we want. So here we want nurse. Come on. Okay, that's it. So I don't need this anyways. This one and this one are coincidence. Nice. So what I want to do is make all of these construction geometry and this one not a construction geometry. Cool. So now I'm gonna pad this all the way through. Now here's a cool thing. How much? I think it was rotating screw params dot screw length. Is it? No, it's not. Diameter, bearing width, bearing tolerance, screw length. Okay, so back to screw. How much is it? Interesting. So it's screw length. Thickness divided by 2 minus bearing width. Wow. Oh wait, I think what we can do is we don't even need a value here, right? Because what we can do is instead of dimension, we can do to last. No faces found in this direction. Is it reversed? No, it's not finding anything. Now we can do up to face and select this one, but this is not parametric. And for some reason it's not covering the entire thing. Okay, let's do this the correct way. So we have thickness plus 2 divided by 2, sorry, plus tolerance. So let's put it here. Okay, or wait, come on. Plus rotating screw parameters dot screw length. where is it here? Rotating screw params dot screw length and this thing right here. So that's plus this, right? Wrong. It's only the first one. Okay, and here transparency 0%. What is going on here? Okay, it's fully closed, but we have these weird faces. That's fine. It's not gonna look like that. But wait, can we do refinement here? I think we can. Oh, it's already set to true. But for some reason it did not merge these faces together. Anyways. Anyhow, what we also need to do is to remove this bearing slot here. So we're gonna do something similar. We're gonna do something similar, which is thickness divided by 2. I'm going to create a sketch on this datum plane. Create a circle that should be the screw diameter, right? So rotating screw params dot screw, no, I think it's just diameter. Interesting. Why is diameter? Is it because of the tolerance? So if I remove no, do we have a tolerance here? We have a bearing tolerance. I'm getting confused. My own design is confusing me. This should be diameter, but it's not for some reason. For some reason. What are you? Yeah, it's bearing tolerance. Why was I doing this? No. So that's minus. I had some very weird design decisions made. Anyhow, we want to pad this by, what is the amount? What is the amount? Going back here, let's see. So this one is thickness divided by 2 with the tolerance, and then I don't care about this one. So we have this. What about this? I think this is the one. So now if I pad this, it's going to be general dot thickness divided by 2 plus general dot tolerance plus this value right here. I think. So basically we remove the division by 2. Is this it? Huh. Interesting. So we're using a different tolerance here than here. Wow. Wow. I'm gonna, anyways, what I think I'm gonna do is go back to this sketch. And what if I used, let me see what happens if I use like the general tolerance. Now it's smaller. What? Oh yeah. Yeah, right. Not the general one. I'm gonna leave it like this for now. I'm just gonna leave it like this. And now I wanna cut here the slot. So we're gonna create a sketch. And we are going to create a circle. This is going to be the motor holder params. No, motor params pin diameter. But I'm gonna add tolerance. So general dot tolerance multiplied by 2, and this is gonna be a slot that will accept the pin. It's quite big. And we also need the trimming here. So from here to here, this used to be motor holder plus trimming. No, motor params pin diameter divided by 2 minus, no, okay, I think I got it. This used to be the trimming offset, which is a bit confusing, but that's fine, divided by 2. And then since this is a cutout, we need to add a tolerance. We'll see how it looks in a bit. So now, oh wait, I need to trim the upper section. Okay. So now I can pocket this. Probably reversed. Okay, it's reversed. Nice. And how much do we want to pocket? This is going to be the motor params dot pin length minus motor params dot trimming length. No, that's not it. I don't know why I did that. That's stupid. It's just trimming length plus a tolerance. Okay, now we're good. So if we show the motor now, let's just make it right. Okay, cool. So if we show the motor now, and I'm gonna take this body to view, increase the transparency so we can see through it. We can see how this pin will go in with an offset, and it's gonna fit right in it. Now we should probably keep it in place somehow, because I don't think we should glue it here. That will make it like irreplaceable, so I'll figure something out. So we don't need this lure holder, that's what we said. We should probably rename this to screw 3. So now we have 3 screws. And this has to be green. I think it was this color. I don't remember, yeah. Okay, cool. Lure holder, no. Screw, bearing 1, bearing 2, moving platform, base plate. Nice. Still don't know what to do with these. So what I was thinking was something like this. Where was it? These. No, I accidentally ordered the fancy stuff by mistake. That's my bad. But these are like tensioning springs. I was thinking we can attach this to this using like 2 springs, and then we have whatever it is attached here. But I don't think this is necessary anymore. I don't know, too many design decisions to make. What I am sure of is I don't like this. I don't like this at all. So I think let's remove it right now because it looks so bad. What is this mirrored? Wait. What did I mirror here? Base plate, motor holder. Interesting. Pocket. It's this sketch right here. Oh, okay. Yeah, I think I remember. This is related to the thing I'm removing. Pad. Pocket. Okay, and then another pocket. Nice. That's how it used to look like. But now we need a different way to attach 2 of these platforms together. Because I'm worried that the previous way that I had, which is basically, oh, come on, click this way, it's not gonna work well. At least the way it is at the moment is not gonna work well because I mean it's gonna hold it in place if there's force along this axis right here. But if there's tilt like that, it's not gonna hold it in place. So one way is to keep this and then insert a pin from this side. Maybe that's a good idea. Maybe we can keep it and insert a pin. This pin could be like a steel wire. Or it could be another 3D printed piece. However, we do have something here that we need to stay away from. These 2 holes. We can insert the pin from this side. Or from here at the end. Should work. Should work. Yeah, I think I'm gonna do that. I'm gonna leave it. I changed my mind again. thick enough to put something. I'm gonna go with, so this is in the base plate. Where's the base plate? Base plate params. Connector. So here we have the connectors. And then we need, let's do pin. So it's gonna be like a rectangular pin. That's like the easiest to print. Let's just do pin size and make it a square pin. Oh, come on. It's gonna take a while. Pin size. I'm gonna go for something like 4 for now. And then I'm gonna give it its own tolerance, like pin tolerance. Or no, we're gonna use the general tolerance. So pin size, and I guess that's it. Come on. It's lagging a bit. Cool. Oh, and pin offset, I think. Let's also do 4. So how will it look like? Let's see. From the front, I'm going to create a sketch on this plane. Something like this. And then we're gonna create a pin right here. Something like that. So from the bottom, or sorry, from the left, the distance is going to be baseplate params dot pin offset. So that's how much material do we want on this side. And then we're gonna make these two equal. So basically we're making it a square. And then this is going to be baseplate params dot pin size. Probably too big. I might make it 3 mil. So that's right here, but then how do we put this in the center of that? This should be, what is the height of this? Base plate params. Rail depth, thickness. So I think it's thickness, which is 15, minus rail depth is like the height, because this is the entire thickness and this is the depth. So if we take the vertical distance, it's going to be baseplate params dot thickness minus baseplate params dot rail depth. And then if we divide the entire value by 2, oh wait, I did the distance to this edge. So I'm gonna copy this, copy, delete this, and then we're gonna do it to the center instead. Vertical distance. Okay, now it's centered. And now if we close this, we can pocket it. We're gonna do through all and then symmetric. So this is gonna create a pocket all around it. But thinking about this now, we also need tolerance, right? So we are going to use the general tolerance. Yeah, I think I'm gonna make it, as I said, I'm gonna make it 3 mil. Nice. And now we need to also cut this side right here. So to do that, we should probably, I think we already have a datum plane here somewhere. No? Binder. No, we don't. So we need to create a datum plane. Sorry, cancel. Yeah, create a datum plane, attach it to this plane in the Z direction. It's going to be, is it in the base plate params? No, it should be in general. Nice, I think that's it. Yes. That's exactly where it should be. And now we can do the same. Oh, wait, no, I don't need a datum plane. But it's good to know that it's general.length. So if I go to the same sketch, I can draw another one here, or I can do a pattern. So if we go to lattice workbench, create a linear array. Oh, come on. Okay, now create a linear array. Where is it? Cool. It's right here. So go to the top. Let's look at it. So it's starting from here. Let me hide some stuff. Electronic box, power supply, board, fan, motor, screws, 3. We only need this at the moment. Okay. It's gonna start from, so in the placement, position, x-axis, we can move it. So this is going to be baseplate params dot pin offset. Basically, I want it to start from here, or let's make it start from the center. Doesn't matter. I think it should start from the center. So we need to also add baseplate params. Actually, no, it doesn't matter. Doesn't matter. Never mind. And then down here, we need to go span n or step n. Step n, and we need to change the count to 2, and then each step is going to be general.length. Baseplate length. Was it? Yeah. So it starts here and then it ends. No. Oh yeah. Yeah, no, that's fine. That is fine. So now if I take the linear array and then the pocket, linear array and the pocket, and then we can do a part design pattern. And now we should have this hole right here exactly where it should be. And we can measure the distance. Let's see, just to validate. So part design, we can measure the distance between this edge and this edge. It is exactly 4 mil, which is our offset, 4 mil. Cool. Let's clear the measurement. Now it changed color for some reason. Why did it change color? I don't know. I'll check the color thing later, but now we can create the pen. This should be very easy. So I'm gonna add a body. Let me see where this body is. I'm just gonna move it to the side. So in the Z, or sorry, in the Y direction, let's move it down. I want to move it by minus general.width divided by 2 plus 20. So it should, wait, what? Isn't it width? Should be width. Width is 100. Oh, wait, minus 20, not plus 20. Okay, yeah, that's it. And now I can create a sketch on this plane. Let's draw a rectangle. Let's make it symmetric to this line. These two should be equal. Where is it? And the width is going to be base plate params dot pin size. And now all I have to do is just pad it by general dot width. That's our pin. So now we can print 2 of these. Use this, whatever it's called, like dovetail or something. I don't think it's called like that. Anyways, this joint. We can join them using this joint and then insert this pin to lock them in place. Should be stable enough, and we can use the tolerance to make it like a press fit or like a loose fit or something like that. So we didn't do much today. All I did was model that screw. Oh, we modeled the motor. So we modeled the entire motor. We modeled this screw. We modeled this right here. And the cool thing about the screw is that now it's supposed to be parametric. Now let me save before I test that. But it's supposed to, when I go here to rotating screw params and maybe change the screw length to like something like 25. Give it a second to recalculate all the stuff, and it should be parametric. Yeah, now all of them are 25 mil. This one, what is this? This screw, it has opacity, so let's turn off the transparency. Did it break anything? Sometimes this happens and I don't know why. So let's return it back to 15 where it was actually working. Yeah, as I said, I might change the threads. So this body here, we're gonna call it base plate pin. And I think that's all for today. Yeah, I can't do much without actually getting the hardware. So this project might have to wait um, till I get all the hardware from AliExpress, which could take time. It could take like a week or two. I think we're at the end of July. Next Monday would be August 5. I'm not sure if they will arrive before August 5, so we might have to wait till the next Monday or even this one. I don't know. We'll see. Because I need to print some parts and test fit everything and see how it goes, and then we can have another live stream where we do some modifications. But for now, that's it. If you have any questions about this project or FreeCAD or 3D modeling in general, or 3D printing or lure design or whatever, make sure to join my Discord server. The link is in the description. Yeah, any question you have, there's me, I can help you, and we have a bunch of people also in the server that can also help you. So hope you have a nice day or night, and see you in the next live stream. Bye.